So composite figures is exactly that. You just add and you are going to look at, they're going to give you some kind of figure and you're going to have to view that as a composite figure or figures combined, a combination of figures that you can find what the area is. Okay, that's basically what we're doing, okay? All right, so let's look at example number 1. Example number 1, we have a figure that's kind of like a L shaped like that. 21, 15, 12, 21, 15, 12. And then we have 27 on the bottom. And I want to know the area of this. Okay, so there are 3 different ways to solve this. Okay. First way is to go like this. Then you have 1 rectangle, you have 2 rectangles, right? Okay, that's one way. The other way is to go like that, right? Then you have this rectangle, and then you have this rectangle. What's the third way?
Make them into the trapezoid. No.
Like this? You can do it like this. Okay, is that what you're saying?
Yeah.
Okay, good observation. I wasn't thinking of that, but that's good, right? Then you have 1 trapezoid, and you have another trapezoid. Okay, but everybody does not, nobody likes the trapezoid equation, right? Third way is this. What is that? So I'm going to take this rectangle and then subtract this rectangle. Do you see that? Does that make sense? Okay, so there's 3 different ways here. So, well, let's try Kyla's method. Let's go. And we're going to do 2 trapezoids just for the fun of it. Okay. So I have this leg and the height, I'm good with that. I have this leg, I need this leg and this height. So this leg would be 27 minus 15, so this would be 12, right? This height would be 21 minus 12. So it would be 9. Okay, so we'll call this trapezoid 1, we'll call this trapezoid 2. So trapezoid 1, the area is, let's have the birthday girl tell us.
Oh, is that me? Oh.
Oh, is that me?
Well, it's not my birthday, so.
Okay.
Okay. Which trapezoid?
Trapezoid number 1.
Okay, so we take base 1, base 2.
Okay, which one is base 1 and base 2?
I'm gonna say it would be 12 and 2. So for 21.
12 and 21. So you have 21 plus 12 divided by 2. And then the height, right? You have to multiply it by the height. Okay. Number 2. Josh. No Josh? Dang it. Who usually sits here? Jose. My bad. Jose. Okay, never mind. I just called you, so I'm not gonna call on you. Tyler.
So base 1 would be 12. Base 2 would be 27.
Correct. And the height would be 9. Okay, and then you would add these 2 together, right? So let's do this to make sure we get the same answer with the book, okay? So I have 33 times 15 over 2. I have 39 times 9 divided by 2. If I add these two together, I'm going to get 33 times 15 plus 39 times 9 divided by 2. Okay. 15, 33, 45, 45, 495 plus 18351 over 2. 648 over 2. 423. Is that what the book got? That's what the book got? 423? All right. So our method worked. Okay. All right. A little bit of the long way, but hey, we got there, right? So that's example number 1A. Let's do B. I think that was a really good exercise to refresh our trapezoid equation here. Now, this one we have like this. And we have 3. This here is 7.8. And we have this here is 10.2. And then, okay. So obviously the easiest way would be to be this guy, this guy, and this guy. This is a triangle, a rectangle, a semicircle, right? We should be able to do that, right? Okay. There's actually another way to do this. Okay, where instead of doing in 3, you could combine these two as a trapezoid, right? So this would be a trapezoid, and then we just add this guy to it. Okay. So what's our problem? What do we need to find? We need to find, so we need to find the radius here, correct? All right, that is not given to us. So that's going to be our first order of business, to try to find that radius, because we need that radius. Once we have that radius, we can find this guy also, right? So actually we're going to end up getting this guy first and then finding out what the radius is. How am I going to be able to find this guy?
If you can find the base of the triangle.
Base of the triangle. Yeah, so the base of the triangle, because this is the base of the triangle. Okay, so how am I going to find the base of the triangle?
You will first take away 3 from 7.8.
Nice. So this would be 4.8.
And then use the
Pythagorean theorem, right? So what we're trying to find here is this guy here. We'll call it L. 10.2 squared is going to be equal to 4.8 squared plus L squared. Okay. And I'm a little lazy. I don't want to figure. So what was, if you do that, you get 9. L is equal to 9 is what you get. Okay. So L is equal to 9, which means that this guy is 9, which means that this guy is 9, which means that the radius is 4.5. Okay, so let's go 1, 2, 3. This was 4.5. Area of number 1 is going to be what? Yeah, give me the equation.
Oh, okay. 4.5
Squared times pi. Is that it? Or is this it? have to divide by half?
Yes.
I have to divide by half, right? Because it's half of the circle, it's a semicircle. All right, so this would have been the entire circle. It's half of it, so I have to divide it by half. 2. 3 times 4, 3 times, L was 9. 3. Triangle here, so it's going to be 9 times 4.8 divided by 2. We'd add them all up together, right? And if you do that, it looks like you get 80.4. Okay. All right, let's do example number 2. Example number 2, we have 1836, 9. And I want to find the area there. So this is fairly evident, right? There really is. I mean, it's kind of shows you what we're going to do, right? We're going to go ahead and do the rectangle and then subtract out the triangle, right? Okay. All right. So how would you find the area of the triangle on this one? Hold it.
Well, the base would be 36, so it'd be 36 times 9 divided by 2.
Okay, so that'll be this triangle. And I'm going to take this rectangle first, right? So it's going to be 18 times 36. I'm going to subtract that out, right? 18, whatever. If you do that, you get 486. Okay? A harder way to do that would have been this rectangle, this triangle, this triangle. Okay. Do I know that these two triangles are the same? They are? Do they look the same? They kind of look the same, doesn't mean they're the same. There's nothing in here that says that these two are the same, right? Because I can actually move this over a little bit over here, right? It would go like this, and I would still have the same result because my triangle area did not change, correct? So there really is nothing that says that this triangle and this triangle has to be the same. Just kind of see where you guys are thinking on that. Okay. Let's look at number B. And number B, we have a basketball court kind of looking thing. It's a little different than a basketball court. Yeah. Can you what? Okay, so this is actually more closer to a handball court. I don't know if you guys ever seen handball before. Right? Handball is like a combination of soccer and basketball. You dribble the ball, right? But there's a goal, there's a little goal in here, goalie stands there, and you can't go over this line. You have to shoot it into the net. I grew up playing handball, so one of my favorite sports. 33 and 16. So I have 33, 16. How would I figure this out? Anybody? So I would take this rectangle, right? I'd have to subtract out this semicircle and this semicircle, correct?
Find the area of the rectangle.
Which is?
16 times 33.
Okay, and then?
And then you take the 16 to be the radius of, or the diameter.
Diameter, right? So which means that the radius is 8. So that would be the area of that circle, right? But it's a semicircle, right?
Yes.
Yeah,
But there's 2.
there's 2 of them. Key point. If I add this semicircle to this semicircle, it actually becomes a whole circle, right? So I can just go like that and I'm done. Everybody see that? Because there are 2 semicircles. Because normally, if I did one semicircle, it'd be that, and I'd have to subtract the other semicircle out also. But I'm going to go ahead and combine these to look like that. That's what we did there. Okay? Very good. So we can do that, and I'm not going to go through the math. It's 326.9, 326.9. Okay, and then we have example number 3. Number 3, we have landscaping. So really, this chapter, as you can see, is there are several different ways to achieve the same goal, right? But you have to look at it and be able to find out what different options you have, and then pick and choose it and go ahead and run with it. Landscaping application. Katie is using the given plan to convert part of her lawn to a xeriscape garden. Anybody know what a xeriscape garden is? I have no idea what a xeriscape garden is. The newly planted xeriscape uses 17 gallons of water per square foot per year. How much water will the garden require in 1 year? So you want to find the square footage to find how much water it needs. Okay. So it looks like we have something that looks like this. Obviously not drawn to scale, 28.5, 7.5, 10.5, 6, 19.5, and the very bottom we have 12 feet. Okay. Looks like the book wants to go like this. 2 rectangles, 1 trapezoid. Not a bad idea. Okay. You could go like this. 1 rectangle, 2, 3 rectangles, 1 triangle. Right? You could also go like that. 1 rectangle, 2 rectangles, 1 trapezoid. Or we could do the other trick that we did before. And we could go like this. Look at the big rectangle. And then from there, we could subtract this trapezoid and this rectangle. Right? Or and go like that. Right? So let's see. Well, I got this drawn out, so let's just go ahead and do this. So I have 10.5. I need to find this guy. So this guy would be this guy minus this guy, which would be 12. Right? I know this guy is 12. I just need to figure this guy out. This is 10.5. I'm good with that. This guy would be, if we add these two together, would be 22 and a half, and then subtract it from there. This guy would be 6. The total rectangle is this. I'm gonna subtract this guy first and then subtract that guy. If I subtract the first one, it is 12 times 10.5. This guy here is going to be 6 plus 12 over 2 times 6. Are we good? Everybody follow that? You follow that? Everybody good with that? And you do, I'm not gonna punch all these numbers in. You do that, you get 375.75. And then, so the required water is going to be this guy times 17, since each square foot requires 17 gallons of water. Okay, so that's how many gallons of water you're going to need. So example 4, I'm not even going to try to draw this on the board. That's a little weird shape there. So we're estimating areas of the irregular shapes. Okay. So I'm actually going to put that on a grid, and you're going to go ahead and divvy it out like the book did to shape A, B, C, and D. So even though these are curves, you're going to say they're close enough to lines, and we're going to count them, or say that they're lines, and then we're just going to go from there. So A is a triangle, as D is a triangle, C is a what? Trapezoid, and B is a parallelogram. Okay. I will ask you this though. So then we do that, and you add it up all together, and the book comes up with a figure of 8. If I asked you, is that an overestimate or an underestimate, what would you say?
Underestimate.
Underestimate, right? Because if you look at it, all of the curves are outside of the lines that you use, that you estimated to be. You see that? So that, therefore, the figure that you got, 8, is going to be a little bit of an underestimate. Okay, right? Okay, we are done. We are done with 10.3.